So I think I'll start. Someone comes along, you have to catch up. So welcome to IoT Cloud Development with Che. My name is Reimann. I'm working for Red Hat in the middleware team with a focus on IoT stuff. So what I want to present today is no. That's not working. That's not working for a reason. There we go. So that is the scenario, the idea that we have. Why do we need a cloud-based IDE? And I want to show that in the context of IoT, because that's what my background is. So the simple scenario is you have the edge, and on the edge you have devices. You have multiple devices, many devices, millions of devices maybe, which communicate with the cloud infrastructure. Now, the communication which you have is telemetry, mostly command and control to some degree, and in the cloud you have your applications. This is what like your custom applications is, your business case of IoT. So you're not doing that just for fun. You're doing that because you have some reason to do that, and so this is where your custom application lives, and probably have some kind of DevOps cycle where you're like continuously building fresh container images. So you don't want to have old and stale container images containing security issues. You want to be fresh there and like have a continuous cycle of building, updating, and deploying that to the cloud. And of course, if necessary, scaling up to like compete with the demand that you might have come from the edge. So the edge is here very simplistic. We don't like care about in this scenario very much about the edge. So there's the Eclipse Foundation's three-tier architecture of sensor, gateway, and cloud. Here we really don't care much what's on the edge. We just know that there are like millions of devices. That's the background that we have. Now, giving more detail to that picture. We have Eclipse Hono. Eclipse Hono is an IoT. Eclipse That's funny. So Eclipse Hono is the IoT, the scalable messaging platform for IoT from Eclipse IoT. It consists of protocol adapters which do translation between HTTP, MQTT custom protocols coming from the edge. You have services, internal services like device registry, authentication, other things, tenant API, whatever. And this will be translated to a messaging layer. The messaging layer is, in this example, what I show you later on in the demo, will be NMAS. NMAS is an AMQP deployment, where you have a router which simply forwards messages between one side and the other, and you have a broker which does store and forward, so it can buffer messages. And then you have up here some consumer of that. So here we go into the custom part of your application. So you get all that IoT payload in your system in a scalable way, and now you want to process that. Processing that in the first step with some bridge, let's call it in this example, which consumes the data from the IoT layer or from the messaging layer, and then forwards this, in this case, to a Kafka cluster. Could be anything else. Could be a different scenario. You could be splitting that up into different consumers, so like routing forward from this router to different Kafka clusters, different storage systems, whatever you like. And also we have the demo gauge in here, which is a small web front-end application. Just as an example, you have some application making use of that data internally. And this is like your custom application stack in that scenario. So I want to give a brief introduction about the different components which we have, so that later on when I just name them, you have at least a glimpse, a clue about what these components do. You saw already a few of them. We have OpenShift, and OpenShift is a Kubernetes-based way of deploying containers, orchestrating them. So I will assume that people know Kubernetes, or at least Docker containers, the way that this is deployed. We have NMAS. NMAS is the messaging layer. So this is like generic messaging without any IoT specifics in that case. And we have Eclipse Hono, which adds, based on the NMAS layer, adds IoT-specific messaging. So more focus on the MQTT, on device registry, and so on. One important thing is that Eclipse Hono basically is payload agnostic, so it doesn't care what's sent over the messages, but it only provides the endpoints and the transport mechanisms. Then we have Strimzi. Strimzi is a project which does help in deploying Kafka inside of OpenShift Kubernetes. So Kafka can be complex to set up, and Strimzi does it for us in this example. And of course, we have Eclipse Che. So Eclipse Che is the cloud-based web IDE, which can also be deployed in containers and in Docker containers, basic and simple. But you can also deploy it in a more multi-user session setup in the cloud. So back to that original picture. This is how this could look like in your scenario, in your setup, your architecture. So you might have something like, as we said, the stack of NMAS, Hono, Kafka on the other side, and you have different custom applications. Now, what probably many of you do is you have some sort of version control system, probably Git. You have the application running in the cloud in some containers, and you have a build cycle which builds from that Git repository, either in a very simple build or maybe in some kind of pipeline build with different steps transferring the Git repository into your runnable application in that container. What you normally want to do is you want to keep that close to the cloud side, so that everything's contained in that productive environment. But the only thing which is not in that cloud side is the local IDE. So coming from a traditional development, you have your local workspace, you have your local IDE, and you have all the problems which come along with that. Like how do you synchronize the projects, the repositories, who uses which formatter to which credentials to check in. And you have another problem, which is all your productive stuff is running in the cloud and you're outside of that network. So there are a few ways how you can punch holes in that network if you need access to that. There's ways like you can replicate that productive cluster, host that locally, but the more you bring that towards this area, to your local development area, the more you modify your productive cluster or the setup, the way you deploy your productive cluster, you get further away from the way you do that. So in the end, it can turn out this is something completely different. And the problems you have solved here are still unsolved on that side in the production. There is, one idea, Eclipse Che. You can deploy Eclipse Che on the same cloud as the other applications run. And so with Eclipse Che, if you start up your application in your workspace, Eclipse Che has either the same container or can spawn up as a second container alongside the Eclipse Che. But this is all happening in the cloud now, and the only thing which you need is a browser to access that. So you're way closer to your actual application which is running. You have still access to the Git repository, to the build system. You can debug or you can access directly from here the components over here because it's way easier to do that in the same cloud environment. So how do you transition to Che? Now, Che can be a tool which can help you in that scenario. However, probably most people will be fond of their IDE on the local machine. So I'm not trying to tell you, look, move everything to the cloud, just ditch your local IDE and go to the cloud. But Che can be a tool which helps you in that scenario. And you can use both IDE versions alongside. So there's no need to go for one or the other. But if you're using a Git repository, you have one entry point from which on you build your application. And so you can use both sides alongside. One important component of that is I think, the language server protocol. So I'm not sure if anyone has heard of the language server protocol. If you have, raise your hand. Yeah. So the language server protocol is one thing which the Eclipse IDE and Eclipse Che both make use of, is that you have language-specific intelligence encapsulated in a process and can reuse that with different IDEs. That's, in a nutshell, the language server protocol. What you can do with that is, for example, you have, we will see later, you have TypeScript intelligence, and the same functionality is available in the Cloud IDE and in the traditional IDE. So you can reuse the same tools with that. So now it's demo time. I will try to show you what you can actually do. Now you see the QR code. If you pick your mobile phone and scan it, I hope this works from a distance. Otherwise, like, come closer, no problem. Or you can just type in the URL up there. That works as well. I will shortly explain what I'm going to do, so you have time to open the QR code. And then we'll switch to the demo. So if you run that, if you open that, the URL, what you will see is a small gauge, which was like showing some random numbers. So has everyone got that? Perfect. So this is like the demo gauge application, which you see on that picture. And this is fed from the GitHub repository, which we will like now edit with Che. The second part is the Camel Bridge, which is also the custom component which translates between Nmos and Kafka. We will also have a look at this in a moment. And I will open now, I'll leave the demo, and we will have a look at the OpenShift instance. So this is an OpenShift instance hosting a set of projects, and this is like basically the set of projects which I mentioned before as those different blocks in the architecture diagrams. I will start with having a look at the IoT workload simulator, because that's a very simple application. It's only one container. It's producing one message per second, pushing that to the MQTT layer of Eclipse Hono, which will then consume the message and forward this in the whole stack. So there's not much to see here. It's a very simple application. The second one is Eclipse Hono. So there it gets a little bit more complicated. So we have different components of Hono. As you can see, you have the protocol adapter for HTTP, for MQTT. You have, on the right side, you see is like always one pod, so it's not scaled up. So the message is not here, okay, look, this is all one pod, this is all fine. But you could scale up massively if you have the requirement. Now, currently we have one message per second, so that's totally fine what we have here. We see an InfluxDB. The InfluxDB is only used for internal metrics, where you can see how many messages come along, and you can do some tracing there. And now the second step is, in processing the data, is the Nmos project. So again, this is the layer of the messaging layer, the generic messaging layer, and here we see again a set of components which we can scale up as needed. So whenever some component requires more CPU power or more network throughput, we can scale up. And here we can actually check. We can look a little bit inside. What's going on. It needs to load a second. And there we see the number of messages processed, how many senders and receivers we have. Not that impressive, so we have one sender, one receiver, but that works for the demo. We can also have a look here inside the different addresses, the messaging resources. So we're focusing on telemetry data only. There you see a delivery rate of 1, that's fine. We have different consumers. And so this is all connectivity stuff, which is going on in the cloud, where from your local ID you normally don't have any access to, for good reason. So how do you like interact with that when you are developing and when you do require the access? Of course, you see there's like many pods which you run in the container environment. You could replicate that locally, but could get quite complicated to set up. So the next thing is the Hono consumer. So we're consuming from Hono. This is the first custom application which we deploy. As you can see down here, there is one build. So there's like a setup which consumes from a Git repository, performs the build, and then deploys the container to that pod. What we can do here is we can look a little bit inside the application, because it's a Java-based application based on Apache Camel. And there you can open a Java console, and you can start to look. So this is JMX, basically, stuff exported via JMX. And what we can do is we can look at the route diagram. So this is basically the core of the application. So we are consuming from AMQP. We are transforming that a little bit to make a key for Kafka. And then we're forwarding this to the Kafka cluster. Well, it's nothing big. Then we can have also a look at the source code here. So this is like the source code of the current running Camel application. And finally, we have so I don't show the Kafka cluster. There's not much to see there except a few other pods. But then we have the demo gauge application. Again, there's a build attached to that. So once we push to the Git repository, it does the build, redeploys. And then I can open this, but this is basically what you just saw on your mobile phone. And you should see the exact same value with a few milliseconds delay because it's like pulling the data from the website. So this is all great. But now we have a look at the Eclipse Che instance. And where do we have the tab? It's always opening that in a different location. So this is Che, and Che is now, as we have the IoT application stack, deployed alongside in the same cluster. There is one Che like main process or main component where you interact with. So you log in. You have a multi-user setup here, and there we have 2 workspaces. Now those workspaces are backed by containers, which we just also saw in the OpenShift overview. We saw 2 containers, and those are the running containers for the workspaces. And what we can do is that we can open that, and first we look at the consumer application. And this is now basically the Maven-based project. So there's nothing fancy there. There's small application, and there we have the main XML file. And the main XML file, if we open that, it will automatically in the background start a language server which provides intelligence for Apache Camel. Now this is the code for the route configuration for the Camel context. And if you look here, so is this big enough to see? Should I zoom in? Does it work? It's all right. Great. And this is the route configuration, which we just saw in the running application. So this is the code for that. What we can do now here is we can start typing. And we go here, say URI, and then we hit code completion. And then it will actually tell you, OK, I can insert these and those routes, I have this and those endpoints, and there's a little bit of intelligence telling you what this endpoint actually means. And this information is coming from the language server protocol. Now, if we close this and head over to the traditional Eclipse IDE, we have the same project here. So we have the same project. It's a Maven project. Source code is checked out. And we also have the same main file. And again here, we can start hitting code completion. And we see the exact same results coming from the same language server, which is run, of course, on my local machine now. But it's providing the same tooling for a different IDE. So if you have tooling like that, this can help you get the transition. So you have the same tooling on the cloud and on the local IDE and don't need to give up anything. It gets more interesting when we look at the demo gauge application. So there's, I did not start that myself. I inherited it from Benjamin Cabet and started to modify that in a way I would like that. And I have no idea about TypeScript. So again, here we have code completion, and that helped me understanding what's going on with TypeScript. You have the syntax coloring, all this stuff, and this is basically all coming from the language server protocol for TypeScript, which you can see is started here down there. You have some log output of that. Now, if we switch back to Eclipse Che, I again can here open the demo gauge application, which is the same TypeScript project, but again checked out in the cloud, running in the cloud. And I can of course open here the source code, and I see again the same stuff. Where we go? Here we go. and typing too fast. So again, same code completion, same language intelligence, just on a different IDE, but you get the same experience. So as you can see, there's an application running. So what I did on the cloud IDE, I did a local startup of that application, meaning that Eclipse Che, the workspace, is running in the cloud, and it fired up in that same container. It fired up this TypeScript application. I will just stop that so that you can see how you can like start that. So pretty simple, like you would do it, on your local IDE. You're firing that up, and you see the console down there. It's starting up, and we will see some log messages in a minute or two, or in a second or two, hopefully. And what you can see is there's a preview URI. So what Eclipse Che can do is it knows that you started some application with exporting some port, some HTTP stuff in this case, and it now allows you to access that from the outside, because your Che workspace is running in the cloud, your test application or your local startup is running in the cloud. Now you need a way to access this from your local browser. So what it does is it exports exactly that. That sometimes happens. Yeah, sometimes the Chrome browser freezes. I don't know why. That's the demo effect. So let's do it that way. Just yeah. So back to that. Back to that. Go here. So, but what you see is now the application actually is running, because it's running from before. We just restarted the browser because the browser had an issue. And you see the log output down there. So it's like consuming now from the Kafka cluster. And now, yeah, now it works. I can click on the link, and I do get the same application, but just running in this local IDE for editing. Now what I can do is I can start making changes. So I'm going along and changing that to red, for example. I'm reloading, and you see it's now red because it's running in that container, which is in the Che workspace, and it can directly read the file changes which are made from the IDE down there. So if you look at your application on the mobile phone, it's still green because that hasn't changed. But now we have this wonderful change to red, and we want to set this into production. So what you can do is you have the Git support as well. So we make the change to red, and we commit that. Now the change is committed, and now the idea is, okay, we could basically use git push to push that to GitHub. However, there's like a small glitch in Eclipse Che, which will be fixed in the next version. So we have to do this from the command line. So we cannot use the integrated Git of Eclipse Che. But here you can see so I have a full command line here and have all the Linux tools which are installed in that workspace container. So there's Git support in there as well. So I do git push, and then I paste in my credentials, which are failed. Okay. So let's take them from here, copy over, paste them in, and there we go. So if I'm quick, I can switch over to the demo application. And now we'll see there's a new build running. Now what happened is that the Git change was pushed to GitHub. GitHub sent back a webhook to the installation, and OpenShift is now rebuilding that container. And you can look in here, so we can see it's build number 20, and the last change is changed to red, which I just did, and now it's building. And of course, you can see here you have all the other builds as well. So if you don't like the change to red, you can revert back to the old version at a later time. And this is also like a very simple build now. It's just running, I think, npm install, it's compiling, and then creating a new image. And now you see there's a rolling deployment. So the new pod is fired up first. It will check if this is working, and then the old one is destroyed. And now if you look on your mobile phone, it should be red, if everything's right. But we can check here as well. So this is, as you can see up here, this is the test one which I had. And if we go in here, look at this. Should also be red now, yeah. So this is the change which we have. Now, of course, we could do, interesting. So yeah, this is a data set coming from some university, and they're providing open data sets. And this is some power consumption, and normally it stays under 5,000, but well, you never know what comes along. So the same thing, let me find the Che workspace, there we go. The same thing is basically, we could do that, there we go. We could work the same way with that camel application. So again, we could make changes here, or we could of course make changes using the traditional Eclipse IDE. So we make changes, we maybe can test that locally to some degree, we can push it to Git, and Git will do the build, and OpenShift will do the build, and will take care of the deployment. So that's the demo. So, like, if you're interested in that, what's to do next, you can have a look at the repository where there's like all the information which I took to make the setup. So if you want to get some information how to replicate that, I'm not saying this is a generic deployment for the setup, but it can help you. You need to paste in your own host names, you need to use your own IP addresses, but basically this is the full setup. It's EclipseCon France. We are here. There are people from Che here. There are people from the IoT team here. There are people from I think from Bosch still here, which can talk you through about Hono, about IoT messaging, about all this stuff. So come to us and talk to us. And also, if you're like interested in general in the cloud IDE, follow the Che project. I think there's lots going on. And as I mentioned before, I wouldn't recommend right now ditching your IDE and switching over to the cloud IDE. But it's a valuable tool, which also helped me during setting up the demo of debugging, of running things, of testing out stuff which you cannot really test from your local setup doing in the cloud. Or it's way harder to do that. So, any questions?
So you said you wouldn't advise now changing from your local IDE to your cloud.
I said I wouldn't ditch my local IDE.
You said now. So
okay.
The aim for
well,
you'd be able to do that.
So the traditional Eclipse IDE has like many years of knowledge, of experience built into the code base. So Eclipse Che is also not completely new, but is like compared to that IDE is a new project. My assumption is simply that it will take a while until that same knowledge, that same experience has gone into that IDE. So I think it's, and this is like my message or trying to get over is, try it out, get some experience, follow that development, and make a decision for yourself on when you think it's ready for you. Well, yeah, of course. If you're doing if you're developing an Eclipse RCP application, going for a cloud-based IDE doesn't make any sense. So in this use case, it does make sense. It's actually a valuable tool which helps you debug. For example, with a mobile phone, the application, I had a different JavaScript library doing the rendering first, which was not mobile friendly, and so you're like debugging with a mobile phone. And you can use the same link on your mobile phone. You can just reload, and it's running in the cloud, so no problem. So how do I do from a public cloud infrastructure attached to my local laptop to test the mobile stuff? So, it's way easier doing that way. So there it helps. Any other questions? So thank you for your attention.